In example number 2, we have our same cost function as we did in example number 1. But now we want to find the production level that minimizes the average cost. We want to find the production level that minimizes the average cost. So that occurs when C prime of x equals C of x over x. The production level that minimizes average cost occurs when the derivative equals C of x over x. So the derivative is 3x squared minus 12x plus 15 equal to x cubed minus 6x squared plus 15x all over x. Now, because this is x cubed, this is x squared, and this is x, you could technically take out a GCF of an x from cost. Making this x squared minus 6x plus 15, which would allow you to cancel the x from the denominator. So even if you don't rewrite it like that, but you just cancel an x from each, that's fine as well. But it's important to remember or recall that you can do that. So now I have 3x squared minus 12x plus 15 equals x squared minus 6x plus 15. So this is a quadratic, so I'm going to get it set equal to 0. So I'm going to subtract x squared, add 6x, and subtract 15 from both sides, giving 2x squared minus 6x equals 0. And then I can take out a 2x, leaving me with x minus 3. Okay, that's crazy because I'm pretty sure that was the same problem I did in algebra today. I was just looking. Okay, so we get x equals 0 and x equals 3 as my two potentials. Now, since we're trying to minimize, we're going to put those out on our number line. We're going to look at 0 and 3. And if we think about the fact that production can't be a negative unit, so x can't be less than 0. So I look at values between 0 and 3, maybe 1. So if you plug in 1, 2 times 1 is 2. 1 minus 3, that's a negative. And then plug in something bigger like 5. 2 times 5 is a positive. 5 minus 3 is a positive, so that's a positive. So what that tells me is that this is decreasing, then increasing. Thus, x equals 3 is in fact the minimum. So if I were to put this into words, since production and cost are in thousands of units, what this means is at 3,000 units, because it's not 3 units, at 3,000 units, the production level will be maximized to minimize average cost. So again, the production will be maxed out, giving a minimized average cost. And if you think about cost, you want your cost to be less. So this will be the point at which the cost is minimized. Okay? You are assigned to design some shipping materials at a minimum cost, again, making sense, you want to minimize your cost. The package will be a closed rectangular box with a square base. So you have to have a square base. So that's X by X again. This time, there are 4 sides to the base and a lid. So there's 2 X by X's on my box. It has a volume of 50 cubic inches. So anytime you see cubic, you think volume. So volume equals 50. Volume again is X by Y because it's a square. Surface area is the amount of box needed. So now I need 2x squared because my box has a top and a bottom, plus 4 sides whose areas are x, y. We're trying to minimize cost. So the cost says that we have 35 cents per square inch of material used for the top. And the bottom is 45 cents. So that's 0.35 x squared plus 0.45 x squared again, because that's the cost to produce the top and bottom. It should make sense to you that the top and the bottom of the box should cost more because they need to be sturdier. And then the material used for the sides is 20 cents. So that would be 0.2 xy. But we have 4 sides, so you need 4 sides at 20 cents per side. Find the dimensions of the box that will minimize the cost. So I am trying to find the derivative of cost. I need to get rid of variable y. 0.35 and 0.45 are considered like terms. So I could add those together. So 0.35 and 0.45 added together gives me 0.8 x squared. And then we have 0.2 times 4, which is 0.8. X. And then we're going to substitute in for y. So y is really 50 over x squared. So we're going to multiply that by 50 over x squared. So you can cancel out an x. And 0.8 times 50 is 40. So I have 0.8 x squared plus 40x to the negative 1. And to minimize cost, we're going to find our derivative. So you get 1.6x minus 40x to the negative 2. And again, we know that we want to get that common denominator. So it's going to become 1.6x cubed minus 40 all over x squared. Finding our zeros gives 1.6x cubed minus 40. So then we get that x equals the cube root of 40 divided by 1.6, which is approximately 2 point something. I don't even know. Where's my phone? $2.92. So that's the value of x, and then to find your value of y, you would take that value and plug it in, so that you got y equals 50 divided by 2.92 squared, which is 5.86. And our units is inches, so our dimensions are in inches. Okay. And then the last example, do you have the company estimating one or the DVDs? Which one? So the one that's up there, okay. I can't remember if I deleted the one question I didn't want to do anymore. Okay, so it says a company estimates the cost in dollars of producing items is C of x equals 2,600 plus 2x plus 0.01x squared. Find the cost, average cost, and marginal cost of producing 1,000 items. So cost is simply plugging in 1,000 into that function. So the cost to produce 1,000 units is $5,600. The average cost is C of 1,000 divided by 1,000, because average cost is the cost divided by the number of units. So that would be 5,600 divided by 1,000. Which is $5.60, and that would be per unit. So again, it would cost $5.60 on average per unit. The marginal cost would be C prime at 1,000. So 2,600 as a derivative goes away. The derivative of 2x is 2, and then the derivative of 0.001x squared is 0.001 times 2 times x. So the cost to produce 1,000 units is $4 per unit. So again, it should make sense that average cost and marginal cost have the same units, because marginal cost represents the rate of change. So the change in cost per unit is changing at $4 a unit, where the average cost is $5.60 a unit, and to produce that many units is $5,600. Okay, and then part B, at what production level will the average cost, so average cost be the lowest. So the production level at which the average cost is the lowest is when the marginal cost equals the average cost. So to get rid of dividing by x, I'm going to multiply both sides by x. And then my 2x's from both sides cancel. I'm going to get it set equal to 0. So I'm going to subtract over that 0.01x squared. And actually, if you wanted, you could even set it up now as a square root problem. Because what you're eventually going to do, so maybe instead of moving over the 0.002, I'm going to subtract over the 0.001 so that I can square root both sides. So dividing by 0.001 and taking our square root, we get x equals 1,612.45. So that is a unit. That's not a cost. There's no money associated to that. So it's 1,612.45 units. But we know that we can't actually produce 0.45 of a unit. So in the case of this problem, you could write 1,612 units would be the production level. You don't want to go to 13 because that would not be the minimum. 13 would take you over. You'd be back down on your parabolic curve. So you want to always round down, not up. So even, well, in this case, 0.45 did round down, but even if it was 0.56, you would round down. Okay? So initially, I thought we would have more time to work through those review problems. I know some of you got a jump start on them. That's fine because you've had study halls throughout the course of the day. So let me look at what the original bracket problems number set were and tell you what I want you to do. Okay, so let's do this. Let's do 1 to 3. Uh, 4 is good, 5 is good. Skip 6. Do 7. Skip 8. So you're doing 1 to 5, 7, I'm going to write it down. Skip 8. Let's do 9 though. I like 9. Well. And then go to 11. Okay, that's it. So 1 to 5, 7, and then 9 to 11. The first few are kind of easy. What is that? 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's like 10 problems.
You want 9, 10, and 11?
Yeah, 9 to 11, yes, sorry. And Maddie, let me look at the one you asked me about.
I feel like it's just me being dumb. The only answer I got was 5. 5 is a maximum.
I have an answer key too, but I'm just gonna actually like do the problem real quick. Alright, find two numbers whose sum is 10, so x plus y equals 10. And for which the sum of their squares is a minimum. So I have two numbers whose sum is 10, for which the sum of their squares, so x squared plus y squared equals a min. What? No, x squared plus y squared equals 0. If it's supposed, the sum of their squares is a min, equals, it doesn't matter what it equals. It's going to, you're going to take the derivative and set it equal to 0. Even if you set it equal to 10, because it's a constant, it's going to 0 out. So I said y equals 10 minus x, and then I said x squared plus 10 minus x squared equals a min, and then I said x squared plus 100 minus 20x plus x squared, so you get 2x squared minus 20x plus 100. And then you took your derivative? No, I just wrote an x. It's 4x minus 20. So you're saying when you did...
Yeah, I said that equals 0, and then I got 5.
So 4 times 4, so it's a negative. I got it's a min.
I must have just plugged it in.
Did you plug into the original, not the derivative?
I might have plugged it in, yeah.
Because if you would, I don't know what happens if you plug into... I'm thinking you plugged into the original, not the... I got x equals 5. So then if you plugged into like the left of 5, you got a negative, and if you plugged into the right of 5, you got a positive. So then it's a minimum. You're welcome. And it, yeah, that's definitely, because then you get 5 and 5. It's okay. Yep.